Hello, Mr. Stoller here. So today we're looking at vertical projectile motion, grade 12. Let's dig in and see. Now, vertical projectile motion, you need to understand the definitions of projectile and also free fall. So what is a projectile? It is an object, okay? It is an object which is given an initial velocity and it moves under the influence of gravitational force. Now, gravitational force is the only one actually affecting the object. Now, let's look also at the free fall. Free fall is motion in which an object is moving under the influence of gravitational force, only where there is no air resistance. So whenever you see the object in air, it means that it's experiencing force of gravity and also what we call air resistance. So we are saying if ever we are taking out what we call the air resistance part, all objects, when they are released at the same time, they will actually reach the ground with the same speed and also what we call at the same time. So we are saying if you had to drop, let's say two objects of different weights. So let's say here you have got, let's say a pen, and you drop a pen here, then here maybe you drop something like, what can we say? We can say an exercise book, or we can say a tennis ball, okay? So here we have got a ball here, then we have got our pen here that is actually dropped. If they are to be dropped at the same time, it means that they are going to reach the ground with the same velocity. So here, velocity of the pen and the velocity of the ball will be actually the same. And the time also taken by the pen and the time taken what called by the ball will also be the same. So we are saying they are dropped at the same time because they're accelerating with this, they have got same acceleration downwards, which we call what called G. So the acceleration is equal to gravitational acceleration because the force that is acting on them is only gravity, force of gravity, which is actually Fg. So here we are saying the G here is 9,8, which is actually the same and is experienced by both objects. Okay, so let's move on and see. Now, equations of motion. Now, we are going to be dealing with what called situations where you need to either calculate the velocity. So you'll be asked to calculate the velocity. You can also be asked to calculate the time and also the displacement. So let's just get to see what called these and understand these equations of motions. So our VF here is actually giving us what we call final velocity. So this one here is final velocity of the object. So it's final velocity and it's measured in meters per second. What about VI? VI is initial velocity and it's also measured in meters per second. What about what we call the A? The A here is equal to our G, and which is equal to 9,8 meters per what we call square second. So this is the gravitational acceleration. Gravitational acceleration. So the only force influencing this, we actually assume that it's only force of gravity, which is Fg. So in that case, the object will be having the same acceleration, which is 9,8. And what is the direction of this one here? Direction of the force here is downward. So Fg, we all know that Fg is a downward force. So it means that also the G that you're talking about also, or the A that you're talking about, is also going down. So it's positive going down. So it's positive going down. That's what you must know. Sorry. So downward. So whenever you decide to say, I'm taking upward as a positive, it means that here, if you say upward as a positive, it means that you are opposing the gravitational acceleration. So it means that you are opposing the force of gravity. Force of gravity is going down and the direction of motion, your opposing direction of motion, you are acting like friction in this case, and in this case here, it needs to be negative. So here, whenever you take upward as a positive, just remember that your gravitational acceleration is actually what called negative, so don't forget that. Okay, let's look also on the last thing here, which is time, which is change in time. This here is actually representing time, and our time here will be measuring in seconds. So it's measured in seconds. What about change in y? Change in y is the displacement, which is the change in position. So this is the displacement. Okay, the displacement here is actually what we call change in position, and here we are saying it's measured in meters. So you must know that displacement is a vector, and if it's a vector, it can be positive, it can also be negative. Then here, if we are to have velocity again, velocity also, just know that when you're talking of velocity, it's also a vector. It have got a magnitude and direction, so it can be a positive, and also it can be what you call, it can be negative, or also it can be positive, depending on the situation there. Now, let's try to see different scenarios that we can see what call in when you're dealing with projectile motion. So we'll be seeing different scenarios, and I'm going to explain to you here how are you supposed to present it on a what call the motion diagram. So here, so for example, here let's start with the object dropped or released from a vertical, from a certain height. So here we are saying if we are to have, let's say we have got some structure here. Let me take this. Okay. Let's have someone there. Actually, what is it? Dropping. So it's dropping. So let's have someone dropping what call the ball there. So this is the ground. Now, what we see that initial velocity, whenever you drop something, our initial velocity will be equal to 0. Then here, the velocity v final will be actually the maximum what called velocity. So it will reach the final velocity, reach the ground with a final velocity, which is actually its maximum. So here is 0, and the velocity will be increasing going down. So here, velocity increases going down. So whenever we're dealing with projectile here, just know that velocity must increase going down. Because why are we saying that? Because that's the direction of the force of gravity. So the force of gravity is going down, and we are saying if it moves what called with the force, it also going to increase. So we see that if you're dropping something, it's going to reach maximum at the top. But if you are to throw something, we'll talk about it, then you also understand what we're talking about here. Now, how now do we represent this on what called a distance time graph or displacement time graph? So here we have got our y. Our y is supposed to show us change in y, and our x here is supposed to show us the change in time. In this time here, it's in second, and here it's in meters. So what are we supposed to see here when we are dropping something? Let's see here. We need to indicate first for us to understand here. Let me just do this one here. Let me take it down, and that's our reference. And we are saying it's going up there. And let's also choose our direction here, which is the positive. So we are saying upward here, we are taking it as positive. So if we take upward as positive, it means that when we are drawing our graph here, it's gonna go down. So here we are saying it's actually because you are going on the negative side. Okay, negative side, how are we saying that? Because we are saying the force is going down and you are opposing, so it means that here we are going actually down. So your direction of the what is it of your graph should be like that. So in this case here, it's more curved. Okay, it's curved like that. What about what called velocity time graph? So velocity time graph, let's see here how it looks like. So here we've got the velocity, meters per second. Then we also have our change in time. Now, if it is like that, it means that our velocity, our gradient here, we need to understand that the gradient for this is actually going down. So the gradient is going down like that, and that shows that our velocity. And our velocity, it shows that it's negative. Why is it negative? Because we are opposing direction of motion. Okay, so whenever we take upward as positive, it means that our direction here will actually be going down. But if we take downward as positive, let me just put it this way here. Let me put this way and indicate what we have here. So we are saying this graph shows that upward is positive, and if we are to draw another graph there that goes up like that, it means that we are saying downward is positive. Okay, then here again also it means that here upward is positive, then here downward downward is actually negative, it's positive. Okay, so downward in that case they will be positive, and our velocity time graph will be actually going up like that. So let's also see here what happens with acceleration. So that's the velocity. What about acceleration? Let's see. Let's actually draw something here and find out what's going on here. So here is your what is it? Here is your acceleration time graph. Okay, let's have that. And let's also have another, or let's just leave that one. Okay, so here we know that acceleration here can be 9,8 positive 9,8 here, or negative 9,8. Okay, so here we've got 0 there, and we are saying here when we have that acceleration, it's our in meters per square second, and here is change in time, which is change in time in seconds. And we are saying if we are going to have our upward as positive, let me just draw these two lines here, these straight lines. Okay, straight lines here, and let's see here, they are not that straight, but we are taking them as straight. Okay, so now here when we take upward as positive, our acceleration is always negative. Remember, we take, and remember, acceleration is constant. That's why we are having a straight line here. Acceleration is constant, and if we take downward as positive, our acceleration will be actually positive. So it's either you draw it like this or you draw it like this, but you need to indicate what have you done to your direction. Which one are you taking as positive? Are you taking what upward as positive, or are you taking one taking downward as positive? Okay, now let's see an example here. Object dropped or released from a certain height. Let's see the example that we can actually try. A ball is dropped from a building which is 50 meters high. Calculate the ball's velocity just before it hits the ground. Ignore the effects of air resistance. So here we can put our scenario here and put the building here. Let's just put something here. So it's dropped from the building, and here is the building. And we are saying when the ball is dropped, it's actually going down. Okay, and if it's going down here, it means that at the top there, we are having VI, which is 0 because it's dropped. And what is happening here? The height, which is change in Y, is equals to 50. Also, what is the V final there? V final is actually the one in question, because we want the velocity at the end here. So now when we are given this, what you always need to do is that find out what is given to you. What is given to you? When you see what is given to you, what are they asking you of? Then when you know that, you can now decide which equation should to use. Now let's get to see here. We are given initial velocity. We are also given displacement. We are being asked of what? Of final velocity. Now let's get to see here which one have all that. So if we are looking at this, we can see that this is the one, this is the real deal here. Why? because we have got the initial final velocity, we are looking for final velocity, we have the initial velocity, we also have the acceleration, we have the the displacement. So here, if we are to check here, let's take upward as positive. So if we are taking upward as positive, our acceleration in this case will be negative 9.8 meters per square second. Now, so we are taking the second equation. Why are we not taking the first? Because we don't have time. Why are we not taking the third one? Because we don't have time. We also don't have time here. So whenever we're not given time, we know that we're going to use the second one. Okay, let's see what we're going to get here. So it's going to be V final squared is going to be V initial squared plus 2a change in y. What is our V final? We are looking for it. What is our V initial? V initial is 0. Okay, what about the acceleration here? Is negative 9.8. What about the height? The height here is equal to, let's see what we have here. The height is equals to 50 meters. Okay. Here, our height should be negative here because it's 50 meters above, and we are starting from the top here. So it's actually 50 meters, 50 meters above the ground. So it's going to be negative 50. Okay. So here, let's see what we get there. So final velocity squared is going to be equal to, let's see what we get there. We have got 2 in bracket, 9, negative 9.8. Let's take it up. Negative 9.8. We open the other bracket, negative 50. So it's 980. And the VF is going to be equal to the square root of 980, which is going to give us square root of answer 14 root 5, 31.3, 31.30 meters per second. Okay, that will be our final answer like that. Or in this case here, if you want to take downward as positive, downward as positive, let me just check here, which is actually the easy one. Downward as positive, it means that our V initial is 0, our acceleration here is 9.8 positive, our also change in y is also positive 50. So it's going to be V final squared is going to be equals to 0 plus 2 in bracket 9.8, which is positive, and also a 50, which will also get 980, and what called the VF there will be equals to 31.30 meters per second. Okay, so we just wanted to show you here, if you have to take down as positive, you are going down, and also the distance will be positive there because you're going down, and in this case also because you are starting from the top and the ball is going down. So in that case, all of them, they are positive. Now let's move on to the next scenario here. Object thrown vertically upward and returns to the same position. So we want to check something here. So you are throwing something. Let's see the ball here going up. Okay, it reaches there, the top there. When it reaches the top, it comes down to the same position. So let's take this one as the same initial position. But what we need to understand when you're dealing with what we call a projectile is that when you throw a ball, it means that the initial velocity here, V initial, the ball, the velocity here will be decreasing. So let me just draw a curve, more like a curve. So what happens here is that from this point here to this point here, we are saying this is the maximum. And what happens that the velocity here, V initial, it needs to start with an initial velocity which is not equal to 0. But when it goes up, it means that it's decreasing. So V decreases. V decreases. going up. So, but here, what we'll have here, it will decrease up until 0. So here, V final, on this case here, V final will be equal to 0. So here, this is the what called lowest velocity. Then when it comes back again, it's gonna be increasing up to and give us our V final. But the V final here, these two are equal. So it will, if it's coming to the same position, the initial velocity, just put it here, Vi is equals to V final. Okay, so because it will come back with the same velocity it left with. So when it's going down here, it's going to be increasing. So let's also understand something here. Let's just put points here. So let's just a point here, which is the same level, and also another point here, which is also what we call the same level. So here it means that, let's call this A, let's call this B, let's call this C, and D. So what we are saying here is that when you're looking at this diagram, our V at B must be equals to velocity at C. What about V at what call it at A? V at A must also be equals to V at D. So the velocity here are the same. What about what else can we also talk about? The height. So it means that change in Y. So we're saying here the change in Y at B. So the height above the ground is also equal to change in Y. What is it? At what called at C. So here we're talking of magnitude, not the direction. So here they are always equal in opposite direction. So equal in opposite direction. So here the magnitude is the same, but the direction is different. So here we are saying here we've got A at A is also equal to the distance above what call at D. That's what we must know here. What about the time? What about the time? The time here that is taken by whatever object that we have to reach maximum is the same time it will take to come back to the ground. So it means that here, if from this point here to this point, which is to the maximum, if it's 2 seconds, it means that it's also going to take the ball to come back to the ground, the same position after 2 seconds. So the total time here will be 4 seconds. So it will come back after 4 seconds. So here, what you need also to understand that is time symmetry. The time symmetry. Time symmetry, it means that the time taken here to reach maximum is equal to the time taken to reach the initial position when it's coming back. So it's always important to know that, guys, when you're dealing with what you call the projectile motion. Let's also see how do they behave, how do they what you call this what you call object behave when we are drawing the displacement. Displacement time graph is gonna be, let's draw something here. So displacement time graph, this is your change in Y in meters, and here we are having 0, and here we are saying it's change in time. So if we are to say, let's take upward as positive, so going up as positive, it means that we are going up. So here we go, the object is going up and comes down. What about if we're taking downward as what we call as positive? It means that if we are to go up, that's negative. So here it means that, let's say here, let's say if you are to take downward as positive, your graph will be different. Your graph would be different. It will actually be starting by going down and going up. Okay, the time is the same here, guys, don't worry. So we are saying if we are to take upward, let me use another color there. So this shows that your graph, when you take downward as positive, when it's going up, it's opposing the direction. So it's actually going down on the graph of displacement. So it will be negative, then it becomes positive when it's going down. So in this case here, is still this here indicates the maximum. Let's label here. This indicates the maximum, and this means that it's going up. This means that it's going down. This one means that it's going up. This one means it's going down. And here is our maximum. So we are saying we take it, we throw it up, then it comes back to the same position. Now, how do we represent this on a velocity time graph? Velocity time graph here, let's see how it will actually behave. Okay, I'm just gonna give you two graphs here. Let's have the first one. Let's take this as going up is positive. So if going up is positive, our initial velocity VI, let's say our VI is there, and it's maybe, let's just put a value there. Let's say it's 10. So if this is our V, meters per second, okay, let's also have our 10 down here. V final. So in this case here, we have our origin here. Then we have our change in time, okay, which is in second. Okay, let me also put the second there. Now, if we are to take upward as positive, it means that when it's going up, the graph, the velocity here will be positive. So we start here with a positive velocity. Then it comes down, it crosses the x-axis up until that point. So what it means here, it means that when it reaches the maximum, remember, velocity is 0. So here is our maximum point. So this one here indicates our maximum. And this one here, our initial velocity. And now when it's going down here, it shows that the velocity here is negative. Velocity is negative because it's going down. It's opposing the direction that we said is upward, which is positive. So that's why you cross it like that. So it means that here is the same velocity, which is equals to 10. So here we are saying the velocity again here is still what we call 10 as final velocity. This is how you are supposed to draw what we call when you are throwing something up and comes to the same position, and when you consider upward as positive. Let's see when you consider downward as positive, how it will look like. So here we have got our velocity, which is in meters per second. Let's also put here our 10. Let's say this is our VI, and this is our V final. So in this case here, let's say it's 10. Here also is 10. Now we have got 0 there, and we have got our change in time, which is in seconds. Then where are we going to start with? If we say downward is positive, it means that our velocity here, the initial velocity will be actually opposing our motion. So in this case here, it will be starting downward. So we are saying it will be negative. So here, when we say downward is positive, it means that the initial velocity will be negative because we are throwing it up, and the downward is positive. So here we're going to have initial velocity which is negative, and it will reach that point there. And we are saying these two here are still equal when it comes down. Okay, and what is our maximum? Our maximum, this is our maximum. This indicates our maximum velocity, our maximum what call point, or our maximum what call, this is reaches the maximum, and where V is equals to 0. Okay, where V is equal to 0, and here we're saying V is equals to 0, and also on top here, when you're talking of displacement, V also will be equal to 0. So that's why here it's passing at 0. We know that what call is actually at maximum, and it's now coming down. When it's coming down, it's actually on the positive side. Why? Because it's the final velocity, or it's going down, which is the direction of the motion that we're talking about here. What about the last part, which is the acceleration time graph? So the acceleration time graph here, which is in seconds here, let's say acceleration here, it's in meters per square second, and it's our origin there. So we've got 9,8. We have 9,8. And we have got negative 9,8. And here, when we are saying upward as positive, downward as positive, it's going to be on top like that. It's going to be positive. If upward is positive, it's going to be here. So here we are saying upward is positive. Always, when upward is positive, our acceleration is negative. When downward is positive, our acceleration is positive. Okay, so always know that difference when you're dealing with what you call your graphs. So here it's our velocity time graph, and this one here is change in x or time graph, and this here is our acceleration time graph. Okay, so that's what we need to understand there. Let's get to see if we can answer something here. An object is projected up vertically upwards. 4 seconds later, it is caught at the same height, point of release on its way down. Ignore effects of friction. Calculate the velocity with which the object was projected upwards. Okay, so here we are saying the what you call the object went up and come back after changing time here, which 4 seconds. Okay, so that's what we know at the moment. That's what we know at the moment. But what we also know, what we can pick here from, we know that our v initial is not, we don't know it, but our v final here on the top here will be 0. Okay, then v there on top here will be 0. Now calculate the velocity with which the object was projected upward. Okay, so here we can say, what are we given? That's the first question. What are we given? We are given v final, which we know the maximum is 0. What about the time? Change in time is gonna be, to reach maximum, we just gonna be divide the time by 2, which is gonna give us our 2 seconds. Then here, what else do we have there? Our acceleration. Let's take upward as a positive. Upward positive. It means that our acceleration here will be negative 9,8. What else do we have there? What else do we have? Let's also talk of our VI. Our VI is the one that we are looking for. So we are looking for VI. Now, let's see here with the equations. Should we take the first one? The first one, we're looking for the VF. We have it. We have it. We have VI. We are looking for it. We have got, what is it? Our acceleration and change in time. So we can actually decide to take the first one. Why not the second one? Because on the second one, we don't have change in, we don't have the displacement. So displacement is missing there. What about here? Displacement also missing. Here, displacement also missing. So you must always check that before you start answering. So here you look what is given to you, then you look for the equation to use. Now, so let's have our equation done here. V final is equal to VI plus A change in t, which is our time. Now V final here is 0. What about VI? VI, we are looking for it. What about what is it? What about the time? The A is negative 9,8. Okay. What else do we have there? We have got change in, so let's put change in time, which is 2. Okay, then we are looking for the VI. So we take the VI, there's going to be negative. VI is going to be equal to negative 19,6. So here I'm not going to just punch it. This is negative 19,6. So it means that our VI in this case here is 9,6. So we divide here by negative. VI is going to be 19,6. Let me just write it nicely here. 19,6 meters per second. Okay, so don't forget to put the units. So this is all. We've calculated in velocity with which the object was projected upwards. So we're looking for the v initial, and we know that it will reach maximum. And now the time here, we know that time symmetry is actually 2 seconds here and also 2 seconds there, because it's half of the time to reach maximum. Now, what is the magnitude and direction of the acceleration at the maximum height reached by the object? Now, maximum height reached by the object, we know that our acceleration here is 9,8 meters per square second downward. So it's positive here. So here, this will never change. Your ball always is having, when it's in motion, is always having the acceleration, same acceleration, it never changes. It's 9,8 meters per square second downward. Okay, that's all that you need to know there. So this one comes a lot also in what call in exam questions, where they're asking you the size of the acceleration, magnitude of the acceleration. Now let's look on the different another scenario here. Object thrown vertically upward and passes the point of projection. Now we are having situation like this. We are saying here we have, well, let's say you're on a building here. Then the ball is released up, then it comes down. But when it comes down, here we are saying it will pass the point of release. So here our V initial here is no longer equal to V final here. They are no longer equal. No longer equal. Here, V initial not equal to V final. This here, V final will be greater than V initial, because we are saying it will pass where it was released. It's passing where it was released. That's why we are saying the V final here will be greater. So that's how you are supposed to actually to show it, when this is how you actually comes when we are to put it on a just to sketch it. But now let's look at the displacement time graph and see what happens. Now here we have got change in time. Then we have got change what you call in y, which is in meters. And we are saying here we will go up. Now when you go up, then you will come down, we are passing the initial position. So here, that's what it means. We are passing the initial position. That's what it means here. So does it look like this? Let me see here. No. We are starting with the initial velocity, which is not equal to 0. So we can't put it on 0 there. So it means that we need to choose first the side. Let's choose the side here, upward positive. Okay, so here let's start. We're starting from our displacement time. Go up, go down. So we are passing the initial position, and we are saying this one we are taking upward as positive. What about if we are taking downward as positive? It means that when you are going down, when you are going up, we are opposing the motion, and here we go up like that. That means that this one here we are taking downward as positive. Now let's move to the velocity time graph. Velocity time graph. So here, let's have our graph there. And let's take upward as positive. Now, if we take upward as positive, it means that let's say we're starting with 10 from 10 here. Let's say here we have got 10 here. And this is our origin 0. Then we have a negative 10. Let's have something like negative 15. Now, what it means here, it means that we are going to start from the 10 because we are saying it's upward is positive. So we're taking it up, then it comes down. It goes up to maximum, then it will come back to the initial position, then it will come to what call to the what call a position which is at the bottom. And now in this case here, what you will see is that this indicates that is the original position. So original point of release where it's having same velocity. Here is our maximum. Maximum height, and here is our actually the what called point of release. Okay, so point of release, and this position here is below and we are saying the velocity here is actually higher. Why is it high? Because it's past the original position, and you know that when it's going down, your velocity increases when the object is going down. That's why we are having this. So when the object is going down, the velocity actually increases. So the opposite here is just going to be true, guys. When you're taking downward as a positive, I'm just going to draw a sketch here, which indicates that this one we're taking downward as a positive. So 10, negative 10, and we say 10, then we say 15, and here we're saying downward is actually positive. Okay, that's what we see. So it's gonna pass the original position, then goes up. But here we're starting it negative because we are saying downward is positive, and we are going on the positive, we are going up. What about acceleration time graph? Acceleration time graph, let's see here. Remember, acceleration is not much of a problem here. Negative 9,8. You know the story, straight line. You know the story here. It's also straight line. And here we've got the change in time. Let me also add there. I forgot. Change in time. Then here we've got the velocity, meters per second. Then here we've got also the same thing, V. We also have change in time. Then here we have change in time. Then we have acceleration, which is in meters per square second. That's what we have. So here we have this. If we are to take what called downward as positive, so you're taking downward as a positive, and here you are taking upward as positive. Okay, now, so let's see here if we can have a question. A child throws a coin vertically upwards from the window of a high building with the initial velocity of 15 meters per second. It strikes the ground traveling at 35 meters per second. Ignore the effects of air resistance. So we are saying here our VI is equals to 15 meters per second. I'm just gonna put here meters per second. Then here our V final is actually 35 meters per second, and here V, we know that this one here will be equal to 0 because that's a V at maximum height. But again, we know also if we are to take at this point here, it's also V, it's also equal to the V here, it's also equal to 15 meters per second. Why? Because of the same height. It's actually aligning with the point of release. So we are saying when it goes up with 15 meters per second, when it's going down, passing the same point, it's going to be having 15 meters per second. Then it continue to increase up until 35 meters per second. Now describe the motion of the coin. So we are saying here it have got what we call acceleration of 9,8. So we're just gonna say acceleration 9,8 meters second. So it in a constant. So it have constant acceleration of 9 meters per second. Now calculate the time taken for the coin to reach its maximum height above the ground. So to reach maximum height above the ground, we actually meaning to say from this point here to this point here. So if we are to check with those from this point here, from this point to this point. So that's what we are asking, being asked of here. So above the ground, here is the ground, but we know that if we throw something up, when it reaches the maximum, that's where that's the highest point. So here V initial, we take it as 15 meters per second. So we're taking upward as positive, and the V final here will be equals to 0 because we are looking at this as our V final in this case. And what is our A? Our A there will be equals to negative 9,8. Why? Because we are taking upward as positive. Now, we are looking for what? We are looking for the time. So time taken. So time is in question here. So we look for the equation that have got time. So which equation have got time here? We can take the first one. Why are we taking the first one? Because we don't have displacement, because here there's displacement, and we don't have that. So we are going to take the first equation. Now, how do we solve this one now? So let's have our equation here. V final is equals to V initial plus A change in time. What is our V final? Is 0. What is our V initial? It's negative 15. Then plus, what is our acceleration here? V final, sorry, V initial is positive, sorry about that. V initial is positive because it's going up. So it's going to be 15 here, plus, what is our acceleration? Negative 9,8. Our time is what we need. Now we take the 15 there, it's going to be negative 15. It's going to be equals to negative 9,8 change in time. Then when we have that, it's going to be what called negative 15 divided by negative 9,8. Then we get our change in time. Then let's see here what we get. Let's have negative, it's going to cancel though. So let's go down here, negative 9,8. What do we get? We get 1,53. So here the change in time will be equals to 1,53 meters per. No. Sorry. Because the time here 1,53 seconds. Okay, that's our answer there. That's our answer. So we're just gonna circulate the answer there. That's our answer. So it took 1,53 seconds to reach the maximum. Let's go to the second question and see what we have. Calculate the time taken for the coin to reach the ground. So here we are looking for the time taken to reach the ground. So VI is 15, V final is 35 meters per second, and we know that here we're going to be dealing with only VI and V final here, because we know the V final, and if we had to take upward as a positive, let's look at it. Our V initial will be equals to positive 15, and what about our V final here? Our V final will be negative 35. What about what you call here we are looking at the time taken. Do we have displacement? No, we don't have, but acceleration, we have acceleration is negative 9,8. What about our change displacement? We don't have it. We are looking for change in time. So change in time is in question. So we're going to look for the equation which also have what we have here. So we're looking for the equation with V final. We're looking for the equation with acceleration with the V initial as well. So without displacement, so it's gonna be the first equation. Now let's get to it and see. Here it's gonna be, let's start here, V final is equals to V initial plus a change in time. Okay, what is our V final? V final is negative 35. What is our V initial? V initial is 15. What is our acceleration? Our acceleration is 9,8, negative 9,8, change in time. And here we are going to have negative 15, negative 35, negative 15 is going to be, let's see here, 35 plus 15, we get 50. So it's going to be negative 50 is equals to negative 9,8 change in time. So here we divide by negative 9,8. We divide by negative 9,8. We cancel here. Our change in time will be equals to 50 over 9,8. So we say this answer here divided by 9,8, and we get what we call 5,1. So our answer there is going to be 5,1 seconds. So it will take the coin to reach the ground after 5,1 seconds. Okay, so let's look on the second question here. Calculate the height of the building. Height of the building. Now, when you're looking at the height of the building, let's just check here. Height of the building here is gonna be, we know that at this point here, we can use this point here as our V initial now, which is equals to 15 meters. But in this case here, it's going to be negative if it's going down. Remember, let's not put the sign there. But let's look here what we are given. We are saying at the size of the building, that's the point of release. So our velocity there is 15 meters per second because it's going down and it's 15 meters per second. So we have got V initial, which is equals to 15 meters per second. Let me just do this here first of all. Let's take upward as positive. And we are saying V initially here is equals to negative 15. What about V final? It's 35. What about, we're looking for the displacement here. So our time, do we have time here? We don't have time. So we can leave the time there. Do we have something with, okay, yes. Our acceleration is negative 9,8. Then let's find out which one can we use. In this case here, we are going to use this. So this is for 3.4. This is for 3.3. So why are we using this one here? Because we are looking for displacement and we have got the also here. But here, why are we doing this? Because we don't have the time from the top of the building. It took the coin from the top of the building to the ground. So we can't deal with the change in time. So wherever there's change in time, we don't want that. So we are going to use the equation here, V final. Let's use a different color here. V final squared is going to be equals to V initial squared plus 2a change in y. What is our V final there? 35 squared is going to be equals to, what is our V initial? Negative 15 squared plus, what is our a there? Is going to be negative 9,8 change in y. What do we get there? We're going to say 35 squared minus 15 squared, because here we're going to get a positive here. So let's say here 35 squared minus 15 squared. We get 1,000. So it's going to be 1,000. It's going to be equals to, there is going to be negative 19,6 change in y. Then here we divide. So if we are to divide 1,000 divided by 19,6, we are going to get 51,0. So it's going to be 51,02. So it's actually 51,0. So here change in y, 1,000 over negative 9,6, which is going to be negative 51,02. which is actually 51, 51 meters. Okay, so it's 51 meters. So you can even put it 51,02 meters. There is no problem there. It's 51,02 meters. Okay, that's what we have there. The negative just showing you that it's actually displacement, and it's actually a displacement going down, and we passed, so it's now negative. We passed the height here, so it's now negative then. So let's move on to the next question here. Calculate the distance that the coin has traveled when it hits the ground. So now when you look at this, we are going to have our VI, which is equals to 15, our V final, which is equals to be 35, and we are being asked here the distance it took, but we also know the time it took, change in time, the time. Do we know the time that it took? Let me see here. Okay, time taken for the coin to reach the maximum. Okay, we don't have that. The time taken for the coin to reach the ground. So we have the time which we found as 5,1. So the time here we have, so time is, let me check, time is 5,1. So it's 5,1 seconds. So it took 5,1 seconds to reach the ground. So let's see here what we are going to do. We are looking for the distance that it took. The distance it took, when it hits the ground. So here, to find the distance it took when it hit the ground, we're going to say okay, so this is a bit tricky because we want the time, the distance it took the coin to reach. So here we only found the distance here, which we found it as 51. So we found it as 51,02, which is actually 51 there. So we only find that, we only know here that distance here is 51. So the missing distance here is this part here. So let's just calculate the distance. It will take the distance here from the top of the building to the maximum height. Okay, so but here we know that the velocity here will be equal to 0, and which will be our final velocity then. So let's try to check here what is the distance upward. So let's take upward as positive. V initial is 15, V final it's 0, and what is it? What else do we have there? We have got, we're looking for distance here, guys. Let me just show you here. We are looking for this part here. So when we are looking for that, we are looking for A is negative 9,8, and we are looking for change in Y. So we're going to take the second equation. Let's take the second equation here because we don't have time. But time we also have it, but we can just we can use even the second equation there, which says V final squared is equal to V initial squared plus 2A change in Y, and we are looking for change in Y. V final there is V initial. Here is V final is 0, is equals to 15 squared plus 2 in bracket 9,8 negative, then change in Y. Then in this case 15 squared is going to be 225. So it's going to be negative 225 equals to negative 19,6 change in Y. Then we divide both sides here. Negative Y is going to be equals to 225 over 19,6, which is going to give us, let's see here, divided by 19,6, we get 11,48. So you're going to say 11,48 meters. So it's going to take the ball 11,48 and also coming back to the same position 11,48. So here it's going to be double here. So it means that our total distance here will be equals to 11,48 plus 11,48 plus 51, which is going to be equals to, we say 11,48 times 2 plus 51, we get 73,96. So it's going to be 73,9. This is the distance that was taken by the ball. So here, remember, we are saying the distance to go up and to come back to the same position here is actually 11,48 going up, and also 11,48 going down to this position here. Okay, so that's what we need to know there. Let's see here if we have the last part. The position of the coin relative to the top of the building at 4 seconds. Now, position of the coin relative to the top, to the top of the building at 4 seconds. So in this case here, what we know here is that we were looking for change in y. Let's change the color there. We are looking for change in y, but we have the velocity, we have the initial velocity, which is 15 meters per second. And what about the v final? We don't know the v final, because we are saying here, we are saying after 4 seconds, we are given time here. So change in time is 4. So we are going to look for the equation that actually fit our situation here. We are looking for change in y, so we want something with change in y, but only with the vi. So it's going to be this equation here. So now we know that we are going to say our change in y is going to be equals to vi change in time plus half a change in time squared. Now, for this one here, our acceleration, remember, is negative 9,8 because we are taking upward as positive as always. Now, let's get to it and see. So our change in y there, change in y is going to be equals to vi. Vi is 15 because we are going, it's going up. That was the initial velocity. Vi times change in time. Change in time is 4 seconds plus half. What do we have here? Our a is equal to negative 9,8. What about our time squared there? It's going to be 4 squared. Now, what do we have when we calculate that? 15 in bracket 4 plus half negative 9,8 4 squared. We are getting negative 18,4. So change in y is going to be negative 8,4. Now, what does negative means? It means that down. So it's going to be relative to the building, top of the building, it's going to be 18 meters, 18,4 meters down. So it's actually somewhere here. So we are saying it's 18,4 meters down. The negative just showing us what call where are we with our actually displacement. Because remember, when we're talking of displacement here, if ever the displacement, if it was up here, it was going to be positive. But whenever you see a negative, it means that it's opposite. So it's going down. It has passed the original position and it's what called 18 meters down. Now let's look at the part where the object thrown vertically upward and passes the point of projection and bounces. Now we are saying we have a situation here where we are saying here is a building here, and this object here it goes vertically upward. Then when it goes vertically upward, it comes down, passes the point, and when it passes the point, what happens to it? It bounces. That's what's going on here. So here we are having a situation where we are saying the ball goes up, and when it goes up, it actually goes down up again. It goes down, goes up again, it's bouncing. Let's look at the what you call the velocity, so displacement time graph. Now, when you look at the displacement time graph here, what you're going to see is that what's going to happen to the ball is that it needs to go up. Then when it goes up, it comes down. Then it passes there. I use the different color here for you to understand. Here it goes up, it passes the original position. Then when it passes the original position here, it comes up again. So that is actually going on there. It's coming up again, and we are saying this is your maximum. So it's coming back again to the maximum. That's what we're talking about here. So here there is maximum where it's actually the velocity is equal to 0, because here is the change. So it's time here, change in time. Let me just put change in time in seconds. And here is change in displacement. Okay, that's what we have there. What about the velocity time graph? So we are taking upward as positive. Let's talk of the velocity, what we call time graph. Now with the velocity time graph here, let's see what we have. Again, let's take upward as positive. Now, when you take upward as positive, it means that the object here is going to start with a certain velocity up here. And when it comes, it's going to come down here. Going to come down past the point. What do we have here is that we have something like this. Let me just show you guys how this should be done. So we have something like this going down. Let me put values here. Let me put 9 here. Let me put 11. Here also a negative 11. Now here is our 0. So what it means that our graph, our object here is starting with a negative 11. It's starting with 11, and it comes down here. It goes up, reaches maximum. There is maximum height. Then after maximum height, that's where the velocity is equal to 0, and it comes to the original position here. And we indicate the original position, point of release. Then it passes that. So it means that here maybe it's negative. Let's say negative 15 here. It's actually higher than that now, because but then again it bounces. When it bounces, what's going to happen here, guys? You must remember something here. When an object bounces, it's going to come back with what is it? It's going to take some time on the ground, and when it takes some time on the ground there, it means that also its velocity is going to change. So the velocity is going to change, it's going to drop. So the velocity is going to be actually down there. So what happens here is that we are saying it will have maybe a velocity here of, we can say, let's say 9. When it bounces back. So when it bounces back, it's going up again, but with a less velocity here. Then when it comes, it reaches a maximum. Again, here is its own maximum, but this maximum is actually below. It's actually below. And when it's below, it just actually shows me that I have made a mistake here. Okay, let me just check here. Okay, so this is how it should be. We should have when it's going up, it's gonna bounce, and when it's bounce, it's gonna go up and comes back. Okay, so when it comes back, it's actually having another, it's actually, it shows that when it's bouncing, it shows that it reaches maximum. It passed the original position, sorry. When it went down here, it went again and bounced here. But when it's coming back to the same position, let's see here, same position. Same position, it means that we are going to have something like this. We're going to have something like this, guys. We're going to have something like this, where we are saying it goes up, it comes down. Then when it comes down, it goes up again. And just say here, it's gonna go again and bounce again. You understand? So it means that it's gonna the maximum height, can you see, is different as well. The height to reach our, so this is our change in y, this is our change in time. Then also here, what you see, this space in time show that this is the time it is on the ground. This is some seconds, small seconds that it's on the ground, and we are saying it has to have some space like that. But then again, when we have something like this here, it shows that it's bouncing and it's starting with another velocity, and it goes on like that. That's all what you need to understand, guys. Let's move on to the second one, where we are saying this one you are dropping it, and when you drop it, it's gonna bounce and comes up. So it means that this is, maybe let's say it's our A, this is our B, this is our C. So it means that it will spend some time on the ground here. So let's see here, if we have to draw the velocity, I will call in displacement time graph. Okay, here I'm just going to draw graphs only here, guys. No questions for this one. So here we are saying if it's going to go, we are just dropping it. And if we are dropping it, how must it look like? Okay, here it means that we are dropping it from a certain height, then it goes the ground, it bounces again here with actually another velocity then. Again, if we are to draw it, what is it, on a velocity time graph? So velocity time, it means that we have got a 0 there, our v meters per seconds, and also change in time there. What are we going to have there? We're going to have, let's take upward as positive. So if we take upward as a positive, we are dropping. So if we are dropping it, it means that we are opposing. So it's going to go down like that. So here we know that when we say upward positive, it's going to go down. It's going to go down like that. Then when it goes down like that, it means that it reaches, what is it? We are dropping it and it reaches maximum here. When it reaches maximum, it bounces. When it bounces, it's bouncing with a positive velocity. Why a positive velocity? Because it's gonna start where it's gonna it's going up now. So it's gonna bounce the positive velocity then. Okay, so here bounce the positive velocity, reaches maximum. So it's gonna reach maximum here. And what is it? So point C. So let's label here. Our point A is where we are dropping here. And here is our point. So in this case here, we are saying this is our point B, and this is also our point B, because the point here we are saying it went on with this one here, it on the ground, and left the ground also at point B. But we can see that what we have with the time that I told you about, that it spends, that's why we are saying actually there is some space here. Then from there now, what we are saying, this is the maximum, and the maximum is at C. So it means that this is our point C. And here it will be actually after that. So if you had to draw this kind of, you actually be ending at C. Ending at C is our maximum height. Okay, so always know that at maximum height, our velocity is equal to 0. Okay, that's all what you need to understand, guys. And I think let's also just indicate the acceleration when you're doing acceleration, how it will look like. So here we have got our change in time, and let's have our acceleration here, meters per square second. Then we have 0 there. We have got negative 9,8. And when we have negative 9,8 here, we are saying it goes like that. Then when it's on the ground, we are saying this is what we have. This is what we'll experience here. Then it will come here. Again, it will continue as negative 9,8. Okay, so upward is positive. Yeah, upward is positive. Okay, so I think for today, for what called vertical projectile motion, I hope you guys you understand and you grasp the important concept. Until next time, bye bye.